Hello everyone, I am Majid from the Department of Archaeology, Naogaon University. It's a pleasure to share with you the findings of our recent research titled Unveiling Ancient Technology, XRF and SEM-EDS analysis of a copper alloy bangle from the early historic site Tekttha, Naogaon, Bangladesh. This study explores how ancient artisans in Bengal crafted metal ornaments and what those objects can reveal about their technological capabilities. So let's begin with a brief overview of the background that inspires this research. Copper and copper ornaments have long been integral to the technological and cultural heritage of ancient Bengal. These items not only serve decorative and symbolic roles but also reflected the metallurgical knowledge of early societies. Despite the frequent discovery of such artifacts across archaeological sites in present-day Bangladesh and eastern India, detailed scientific investigation into their production techniques remains limited. Our research focused on a copper alloy bangle recovered from the early historic site of Tekttha in Naogaon, Bangladesh. As you can see, the map shows the location where the studied bangle was found. Let me now walk you through the main goals that shaped our research. This study was designed with three core objectives. First, to determine the elemental composition of the copper alloy bangle using precise, non-destructive analytical methods. Second, to identify the method of production, particularly whether the artifact was cast or hammered. And finally, we aim to interpret the rationale behind alloying decision made by ancient metalworkers and how those choices impacted the bangle's functionality, durability, and aesthetic qualities. To achieve these goals, we adopted a carefully structured multi-step research methodology. We began by documenting the bangle through measurement and visual inspection to understand its physical characteristics. Following that, we used energy dispersive X-ray fluorescence, commonly known as ED-XRF, to determine the elemental composition. We then employed scanning electron microscopy paired with energy dispersive spectroscopy or SEM-EDS to examine the internal structure, surface texture, and manufacturing traces. Together, these methods provided a comprehensive understanding of both the composition and craftsmanship involved. Before conducting the scientific analysis, we first carried out a thorough physical assessment of the artifact. The bangle was found in two fragments. Unfortunately, we didn't find broken parts of the bangle. Its total inner circumference was approximately 131.5 millimeters, with one broken segment measuring just over 42 millimeters. The two parts weighed 15.25 grams and 17.46 grams, respectively. These basic measurements were essential for evaluating its design, wearability, and for guiding our sampling process. In the sample preparation stage, a 3 mm thick cross section was taken from one part of the bangle using a hexa blade and vice. The surface was carefully crowned and polished using various grades of abrasive paper and aluminum slurry to achieve a smooth, reflective finish. This meticulous preparation allowed us to capture high-quality SEM images and obtain reliable XRF data for further interpretation. Now, let's take a look at what the scientific analysis revealed. The EDXRF analysis showed that the bangle is primarily composed of copper and zinc, roughly 45% and 38% respectively, identifying it as a brass alloy. We also detected small amounts of nickel, iron, and other trace elements. The presence of nickel, though minor, may indicate intentional alloying to enhance the strength, hardness, and corrosion resistance of the brush, thereby improving the durability and overall quality of the bangle. Same imaging showed equiaxed grains and uniform metallic matrix, which are strong indicators of casting as opposed to hammering. There were no signs of deformation, supporting the conclusion that this object was manufactured using a controlled casting process. The combination of XRF and SEM-EDS results strongly indicates that the bangle was made using a copper zinc nickel base alloy with deliberate additions of other elements to improve durability and casting performance. The uniform microstructure and absence of hammering marks reflect advanced metallurgical knowledge, including the ability to select and manipulate materials for specific functional outcomes. Such technological choices demonstrate a refined understanding of alloy behavior by early historic metalworkers in Bengal. In conclusion, this study provides valuable insight into ancient metallurgical practices in Bengal, highlighting a level of technological sophistication that has been underexplored until now. By applying scientific techniques to cultural artifacts, we are able to reconstruct the decisions and skills of ancient craftspeople, bridging the gap between material culture and technological history. Thank you so much for your attention.